Hey guys, in this video we are going to play the game Odd Man Out, and this video is going to randomly pause so you can select your answers and then you'll be able to check them. Alright, let's go ahead and get started and play. So, which of these is the odd man out? Which of these does not belong? We have sand, hard-boiled egg, a ping pong ball, and coins. Which one does not belong? If you said the ping pong ball, you are correct. So the ping pong ball is the odd man out. The sand, the hard-boiled eggs, and the coins all have something in common that the ping pong ball does not. What property do the others share that the ping pong ball does not share? What is the property that sand, a hard-boiled egg, and coins have in common that the ping pong ball does not have? If you said density, you were correct. So a ping pong ball is less dense than water, and sand, a hard-boiled egg, and coins are more dense than water. How could we prove or test this? What experiment could we do? If you selected fill a beaker with water and then place each of these objects inside of it and observe, you were correct. So if we wanted to test this out, we would fill a beaker full of water. We would place the ping pong ball, the sand, the hard-boiled egg, and the coins inside the beaker and observe what happens. If it is more dense than water, the items would sink. If it is less dense than water, the items would float. And we would notice that the sand, hard-boiled egg, and coins sink, but the ping pong ball will float, making it less dense. Okay, next one. Which of these is the odd man out? We have black pepper, sugar, salt, and Kool-Aid. Which of these is the odd man out? If you said black pepper, you are correct. So sugar, salt, and Kool-Aid all have something in common that black pepper does not. What property do the others share that black pepper does not? What do sugar, salt, and Kool-Aid have in common that black pepper does not? If you said solubility, you are correct. Black pepper is not soluble, but sugar, salt, and Kool-Aid are soluble. And how could we prove or test this? If you selected fill 4 graduated cylinders or beakers with water and pour in each of the substances, mix, and observe, you are correct. So after we pour black pepper into water and we mix it, we will observe that the black pepper is still visible. We can still see it, and it is insoluble. However, when we pour in sugar, salt, and Kool-Aid, the particles become evenly distributed, so it's very difficult to see. We can't see it. It's still there because we can taste it, but we cannot see it like the black pepper, meaning this is soluble in water. Okay, which of these is the odd man out? We have glass, water, aluminum cans, and a copper penny. If you selected glass, you were correct. So what property does water, a copper penny, aluminum can have in common that glass does not? If you selected insulation or conductor, you are correct. So the water, aluminum can, and a copper penny are good electrical conductors, but glass is not a conductor, it's an electrical insulator. And how could we prove this? We could prove this by, we could connect it to a circuit and see if a light bulb would light up. When we connect a piece of glass to an electrical circuit, the light bulb will not work, meaning it is an insulator. However, if we were to connect an electrical circuit with either water, an aluminum can, or a copper penny, it will work, meaning it is an electrical conductor. Which one is the odd man out? You have a copper penny, keys, a paper clip, and aluminum cans. If you selected the paper clips, you were correct. Now, which property do the others share that the paper clips do not? So the paper clips are magnetic, but the copper penny is not magnetic. The keys are not magnetic, and the aluminum cans are non-magnetic. And how could we test or prove this? What could we do to see if something is magnetic or not? We could hold a magnet to each of these items and see which one would be attracted to a magnet. And when we would do this, we would see that the paper clips are attracted towards the magnet, whereas the penny, the keys, and the aluminum cans are not. Which one is the odd man out? We have a fabric oven mitt, a cooler, a jacket, and a metal pan. If you said the metal pan or pot, you were correct. So, why is the metal pot or pan the odd man out? What property do the others share that the metal pot does not? If you picked thermal conductor, you are correct. So the fabric oven mitts, the cooler, and the jacket are all going to be thermal insulators, whereas the metal pot is going to be a thermal conductor. And how could we prove or test this? If you select measure the difference in temperature, so we could boil some water, take the temperature of it, and place it in either the metal pan, the oven mitt, the cooler, and the jacket, and observe after a few minutes the starting temperature and the ending temperature. If there is a big change in temperature, it's a conductor, meaning the thermal energy flowed out of the water and into the pan. If it was a small change, means it was a thermal insulator, meaning that the material kept the heat inside. Which one is the odd man out? A beach ball, a button, a piece of cork, and Legos. If you selected the button, you were correct. So what property do the others share that the button does not share? What property of matter? You selected density, you are correct. The button is more dense. The beach ball, the piece of cork, and the Legos are less dense. And what can we do to test or prove this? You selected fill a beaker with water and place each object into the water and observe what happens. You are correct. So the button is more dense than water, so it's going to sink to the bottom. The Legos are less dense than water, so they are going to float. The cork is less dense than water, so it's going to float. The beach ball is less dense than water, so it is also going to float. Which of these is the odd man out? We've got silverware, metal lock, a toothpick, and a pencil. If you picked the toothpick, you are correct. What property do the others share that the toothpick does not have? If you picked insulator, you are correct. So the paper clip is an electrical insulator, whereas the metal silverware is an electrical conductor. The metal lock is an electrical conductor. And if you notice, there's a piece of metal up here at the top of the pencil that is also an electrical conductor. How could we prove or test this? We could connect a circuit and then add the paper clip, the silverware, the metal lock, and that metal piece of the pencil and see if a light bulb will light up. If it does not light up, it's an electrical insulator. If it does light up, it's an electrical conductor. And that is our game. Thank y'all for playing. Hope you had fun.